Hello, today we're going to use the composite argument property to solve for equations. The first thing we're going to do is look at the tangent property of tangent of a minus b. Now, I have this one written out uh, so I'm just going to page down when it's time. We're going to do this step by step because there's one real tricky part here. If I take tangent of a minus b, hopefully everybody knows that tangent is sine over cosine, so that step should be pretty easy. And if we expand sine on top, sine A cosine B minus cosine sine A sine B, and so on, and we expand the bottom using the composite argument properties for each of those. Now here's the trick. Now to get to our desired location, we're going to divide each part of this by cosine A cosine B, which looks kind of messy. But I divide this first part by it, the second part by it, the third part by it, and the fourth part by it. Now, I don't assume that anybody would come up with that on their own. However, hopefully you can follow our logic through this. Now, once we do that, now we can start canceling things. Cosine b's cancel out, cosine a's cancel out, over here cancels out to 1, and nothing cancels out here. However, there's a whole bunch of tangents. Sine over cosine, sine over cosine, 1, cosine, sine over cosine, sine over cosine. So we can convert all those to tangents. So once I break it down to here, then I can say tangent of A, tangent of B, over 1 plus tangent A times tangent of B. Now, we can, that's our composite argument property. If I want to do this for A plus B, we can do it similarly, or we can do it how we did the other ones with, we could say it's tangent of A minus negative B, and the minus, we'd have tangent of A minus tangent of, should say negative B, over 1 plus tangent of A times tangent of negative B. So to prove this, this is the composite argument property. So tangent of negative B is just negative tangent of B. So that changes the sign on top to plus. And same thing on the bottom, that changes it to minus. So the proof is pretty short, especially assuming we know the previous composite argument properties. All right, so now we're going to solve equations using composite argument properties. The first one is this one. The problem here is that there's two thetas, so we need to combine this whole thing into something with only one theta. Now this is sine A cosine B, cosine A sine B. Since this sine and cosine are on the same side, we know that this is a sine composite argument property. Since it's addition, we'll do with sine, that would just be addition. So that's sine of theta plus 35. And if you have the chart, that I use the rule number 13 for the composite argument property, sine of A plus B. Now, this is equal to 1/2. Once we get it here, it's the same thing we did last chapter, where the opposite is 1 over 2, 1 over 2. Now we should know that that's 30 degrees and 150. So we divide this up into theta plus 35 is equal to 30 plus 360k, and theta plus 35 is equal to 150 plus 360k. Now if we subtract 35 from both sides, theta is going to be negative 5 plus 360k. And if I subtract 35 from both sides here, theta is going to be 115 plus 360k. So if I wanted to find the values between 0 and 360, I would just be 355 and 115. All right. Now we'll keep rolling. Now if you feel like you're doing pretty good at this, pause the video, see if you can do this on your own, and then when you're done, play it back. Now, this is cosine cosine plus sine sine. So this is, we can break it down to cosine Since it's plus, and cosine is the opposite of what you think it should be, so there will be a minus. My a is 3x, my b is x, so now we just can combine this to be cosine of 2x is equal to negative 1. So now we have to think about where cosine's negative 1, and our cosine is our x value. It's only going to be negative 1 at pi, and we're using pi now because we're dealing with an x. So 2x is going to equal to pi plus 2 pi n. If I divide each side by 2, this would be pi over 2 plus 2 over 2 cancels out, so this would be plus pi n. So this is my equation for the general solutions. If I want my specific solutions between 0 and 2 pi, it would be pi over 2 and 3 pi over 2. Alrighty, moving on. So if I have tangent, or if I have this whole mess over here, I can see that this is addition and that's subtraction. So I have to do tangent of a plus b. So my a here is theta. My b here is 27. Now, a lot of this is just recognizing that this here is equal to this. Because once you do that, then the rest of it's all just like the previous chapter, where tangent is 1 is up here and down here, which is at 45 and 225. So if I have theta plus 27 is equal to 45 plus 360k, theta plus 27 is equal to 225 plus 360k. Now subtract 27 on both sides, and 45 minus 27 should be, is it 18? Yep, plus 360k, and then subtract 27, and I get 198 plus 360k. So those are our general solutions, and our specific solutions would be 18 and 198. Now, again, try this one on your own if you're getting it. We take this, sine cosine, so we know it's sine. There's a subtraction, so we're going to subtract 5x minus 3x. So that's going to be the sine of 2x. So now we got to look where sine is 1/2. I think we've already done this. That's at 30 degrees. And over here at 150. So 2x is going to, oh, and this is x, so hopefully you're saying, reminding me to go to radian. I almost made a mistake there. Pi over 6 plus 2 pi n, and 2x is equal to 5 pi over 6 plus 2 pi n. Now if you divide by 2, this would be pi over 12 plus pi n. If I divide by 2 over here, this would be 5x over 12 plus pi n. So this would be pi over 12. If I add 12 twelfths to that, that would be 13 twelfths. So 13 pi over 12. 5 pi over 12 is the solution. If I add 12 twelfths to that, I get 17 pi over 12. And those are our 4 solutions. All right. Now there's a different type of a problem where we want to find the cosine of a plus b given a diagram like this. Well, we can't figure out these angles without a calculator, but what we can do is we can expand this to cosine a cosine b minus sine a sine b, and I could find the cosine of a, cosine of b, sine a, and sine b. Now, if I have 24 and 25, this side would be 7 units long, and if I have 17 and 15, this side would be 8 units long. These are Pythagorean triples, so it helps to know your triples. Cosine of A would be 7 over 25. Oh, and if you don't know your triples, you can always use do the Pythagorean theorem by hand, but that takes a little bit longer. Cosine of B would be 15 over 17. And then sine of A is 24 over 25. Sine of B is 8 over 17. Now, if we multiply these, 7 times 15 is 5, 3, so 105. And uh, 25 times 17, whenever I multiply 25 by a number, I think of quarters. Like if I have 17 quarters, how many would that be? So I know 4 quarters is a dollar. And so 16 would be $4.25. So this would be $4.25 also. And then 24 times 8. Um, Whenever I do that, I do 25 times 8, which is $2. And then I have to subtract out 8 from that. So that would be what? 192. All right, when I subtract these, this goes down to negative 87 over 425, and we have our answer. Let's try one more like this. Sine of a plus b, we have to expand sine of a cosine b plus cosine of a sine b. So the sine of a, I'll fill in my values again. Sine of a is 24/25. Cosine of b is 15/17. Cosine of a is 7/25. And the sine of a is 24/25. And it's nice that we're using the same thing so we don't have to think about the numbers as much. Ooh, 20. Did I do something wrong here? Cosine of A is 7 over 25. Sine of B, oh, that's what I did wrong. I did sine of A. So sine of B is 8 over 17. So 425, 425, this becomes 56, and this becomes 24 times 15. Um, so if I do 25 times 15, that would be 375. So 360 if I subtract 15 from it. All right, now if I add these up, I get 416 all over 425, and we're done. Alrighty, now we're going to find some more trig exact values based off of trig exact values that we already know. So this one says show that cosine of 15 equals this. Basically, we can just say now we can find trig exact values of cosine of 15. We can do that because we know 15 is 45 minus 30. And now if I expand this using our rule, now we can plug in the values for these. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. And the sine of 30 is 1/2. So this is root 6 over 4 plus root 2 over 4. And when those add together, we can just put it into one fraction, and we have proven that. Now, it gets trickier when it doesn't really give you the answer right away. Cosine of 75. Now we have to think of what numbers add up to 75 that we already know the values of. And the answer is cosine of 30 plus 45. So when we do that, that's cosine of 30 cosine 45 minus sine of 30 sine of 45. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is 1/2. Sine of 45 is root 2 over 2. So this would be root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. And there is our answer. Alrighty, now hopefully you are ready to do the homework. Good luck.